Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Muhammad Irfan bin Kamaru Asri and my group will be presenting about linear programming application in construction industry.
I'm Nur Akila binti Isman.
Hi, I am Sarah binti Farul Razi.
I am Noraihana binti Abdurrahman.
I am Anis Shafika binti Alias.
I'm Farah Adila binti Azmi.
I will explain the introduction of the linear programming. So, the construction industry have contributed to the growth of economic Malaysia. However, construction industry are undeveloped in terms of precise management and computer integrated production system. And they introduce the new technology and scientific management ways into the construction industry, and it can improve the assembly cost benefit ratio, which is the linear programming method. Linear programming method is a mathematical method or technique that has been used to optimize all resources and time to make the most of it. So they apply the linear programming method to the global, which is they use for the economics and business either to maximize income or to minimize management the cost of production system. Many fields use linear programming techniques to make their process more efficient, which is such as food and agriculture, engineering, transportation, manufacturing, and energy. They also use the linear programming for the construction, which is they manage to the construction to optimize the use of available resources and many other optimization problems, which is they determine the most economical combination of products, transportation, and routing challenges, employee distribution tasks, and etc. The problem is to be solved using linear programming is to minimize or maximize some particular feature. This can be maximize profit or minimize loss.
The advantages of linear programming are it helps in decision making, where it shows how a decision maker can pick and distribute the resource efficiently using the constructive method, and this technique can enhance decision efficiency. Other than that, it also helps to decide the leveling of capital, as inadequate resource can well affect the length of the project, and the key problem can be defined by the linear programming in a manufacturing phase. However, it also has a limitation that may not be an integer as the solution, such as a fraction may not be an optimal solution. So, the technique of linear programming can provide a valuable practical answer that is not desirable.
Hi, I'm Raihana. For our presentation, I'm going to brief about the company that we select for this case study. BTS Engineering Syndrome Berhad, BTSE, has been established by Muhammad Asri bin Saidin and Safaruddin bin Maktahi, who have been actively involved in management and cooperation for this company since the inception in February 1996. This company currently operates at Klang Selangor. BTSE has registered with Ministry of Finance Malaysia, Pusat Hikmat Contractor as A-class contractor, and CIDB as Grade 7 contractor with 100% Bumi Putra standard. BTSE range of activity include land and marine geotextile work, slope protection work, construction, civil engineering works, project management, and earthwork.
Hi, my name is Muhammad Irfan and I will be explaining about the first problem, that is how to optimize the labor and machineries present in the construction company. So one of the problems is that there are two types of machineries that can be used for excavation work, but they have limited labor and limited machineries required at hand as well. So the machineries, as you can see on the screen here, that is hydraulic excavator and backhoe loader, and it is used to excavate trenches of 2000 meter cube of soil. So moving on to the next slide. So for the quadratic or linear programming, as you can see here, so first we will of course need to define the variables. So X is the hydraulic excavator and Y is the backhoe loader. And then we have to identify the constraints on hand. So for the machinery strength, we will do these equations. So 20x plus 10y is is equal to or less than 275. So you get these values. The same goes for the labor rates as well. And this so moving on. So this is the graph. So based on the constraint given, this is the graph that was produced based on the constraint. So as you can see here, this is the shaded region. So this shaded region represents the best possible outcomes that can be obtained from the constraints on hand. So these 5 red dots here represents the points or the coordinates that has the potential to become the most optimum choice. So moving on to the next slide. So for the fourth slide, we will have to identify the objective function, that is to optimize the machineries and labor on hand. As I said before, this is the coordinates from the 5 dots that we can see on the graph before. So this is the combination of the machineries, rent, and the labor rates. So you get 880x plus 160y. So it will be multiplied by the coordinates that were provided from the graph before. So the best possible outcome for this one is that 0, 8 coordinate, which is 8 units of backhoe, which is 4,480 ring rate. So this is the best possible choice. But even though this is the best choice, in my opinion, actually maybe utilizing 2 and 7, which is 2 hydraulic excavator and 7 backhoe, is the next best thing, as it utilizes both options rather than just focusing on one machinery.
I will be presenting about the optimization of construction workers. First, we need to identify the problems. There are few times in this project that the workers has no job assigned to them. This means that the number of workers employed is not optimum and the workers are not well distributed for their job assigned. Therefore, the cost spent is at wastage because the total wages paid per day is not at optimum level. There are unskilled workers and skilled workers. They are assigned for bricklaying and transporting materials. After identifying the problems, we need to find solution. First of all, we need to define variables. In this problem, X is skilled worker and Y is unskilled worker. After that, we need to identify constraint. The equation for transporting materials, bricklaying, and wages of workers per day has been developed. One of the constraints in this problem is that one skilled workers must work with at least 2 skilled workers. Next, after defining variable and developing equation, a graph of linear programming can be established. The result from developing linear programming solution is the optimum level can be found at the feasible region shaded in the picture. There are 3 coordinate points that is optimum for the solution. Last but not least, we need to identify objective function. Objective function is to optimize total amount of cost for wages of workers per day. In order to know that, we need to substitute the coordinate points in the equation of wages of workers per day. From there, we can identify which coordinate points that is the most optimum. Coordinate x value is 6 and y value is 13 is said to be most optimum, as the number of workers to be employed and total wages of workers per day that need to be spent is optimum rate. Therefore, the number of workers to be employed are 6 skilled workers and 13 unskilled workers. The rate of total wages of workers per day at optimum rate, which is RM 1450.
Hi, I'm Farah, so I'm going to explain the problem faced by the company when ordered concrete and formwork from the supplier Sbeq is scheduled to deliver by next week. But there are 2 types of pad footing, PF1 and PF2, that need to be installed with limited resources at the same time. So, what can he do to optimize the limited resources and time? The first step to solve the problem is define variable. X equal to PF1 while Y is PF2. Next, identify the constraint based on the table above. As we can see from here, there are 5 constraints to build graph for the next step. The equation made from the constraint has built a graph and see there is shaded feasible region. From that shaded, we can pick the feasible point and put it on objective function, which is P equal to 40x plus 60y to know the most optimized times and material, and the answer is x equal to 8 and y equal to 15 with a total time taken of 1220 minutes. So by doing that, there are another 480 minutes more to install the balanced pad footing.
The main conclusion drawn from this topic is that in order to have a successful project planning and scheduling, linear programming as a management strategy tool must be implemented by the building party, particularly the contractor early at the initial stage of the project. It helps to control and optimize the available resource in decision making, such as human resource, plant and machineries, which provide maximum returns. Thank you.